Hello everyone. In this video, I will be talking about the second learning objective of chapter 21. This is learning about significance level and p-values. So significance level and p-values are two important concepts used in hypothesis testing. So first of all is significance level. Significance level is a preset probability. Okay, preset probability I'm saying because for all hypothesis testing we use either of 1%, 5%, and 10% significance level. Okay, that means your significance level can be 1%, 5%, or 10%. Now what is this significance level, or what is this critical probability? The significance level is a critical probability or preset probability that how likely a statistical inference that we make by a hypothesis is true. Okay, what does it mean? Let's say that you make a hypothesis that average income of male equals to average income of female. This is your statistical expectation. Average income male equals to average income female. Now, significance level is a preset probability that how likely this inference or this statistical expectation is true. Okay. Now, what p-value is? P-value is a calculated probability. So the difference between significance level and p-value is significance level is critical or preset probability, whereas p-value is calculated probability. So p-value is calculated probability that how likely the statistical expectation that we make in the hypothesis is true. Okay. Now you understand that p-value, if it's a low p-value, it means that very less likelihood that expectation is true. If p-value is higher, that means there is a high likelihood that expectation will be true. So for example, if you take the same example again, average income level of male equals to average income level of female. If your p-value is, let's say, 0.5, its p-value is higher, there is a high likelihood that this expectation is true. If p-value is very low, let's say 0.001, then that's a very less likelihood that this expectation is true. Now, how do we decide that whether we accept or reject a hypothesis? We compare p-value, that's calculated probability, with the significance level, that is standard or preset probability. If the p-value is less than the significance level, we reject our null hypothesis. And if p-value is greater than the significance level, we accept our null hypothesis. So if our p-value is, let's say, 0.001, so it is less than the significance level, either 1%, 5%, or 10%, we will reject null hypothesis. Let's say our p-value is 0.8. So it is higher than the significance level of 1%, 5%, or 10%, so we will accept our null hypothesis. Look at this example. Here, this is our standard or a benchmark value, and this is our sample mean. And our statistical expectation is both of them are same. That means the sample mean and a predetermined mean are equal. Now, you understand that as this sample mean gets closer and closer to this predetermined value, there is a very high likelihood that they will be same. So you can see that your p-value gets larger and larger. So as it goes closer to this predetermined value, p-value gets larger, it means there's a high likelihood that your expectation that both of them are same is true. However, as this sample mean goes away and away from this standard, you can see that your p-value gets smaller. It means that there is very less likelihood that the expectation you make is true. Okay. Now, if you take this example, for example, your p-value is 0.001, it's less than the significance level, 1%, 5%, or 10%, because 1% means 0.01, 5% means 0.05, and 10% means 0.1. So this p-value is less than the significance level. In that case, we will reject our null hypothesis. However, if your p-value is here, 0.5, it is higher than significance level, so we will accept our null hypothesis that these two are same. So this is the end of this learning video. We will discuss an example of a hypothesis testing in our next video. Thank you.